Here's the second part of the Bayes calculator project. This one's mostly the hardware side of things, so actually building the case for it, the front panel, the electronics, and I also look at the code at the end, so this should put all the pieces together, and I'll show you the finished calculator at the end of this. And then I'll save the third video, will be more just going through some examples of using the Bayes calculator for doing Bayesian calculations, and it's kind of the enjoyable bit for me because that's why I got into making this calculator, because I was fascinated by the Bayes theorem and what you can do with it. So I started off with cutting a frame for the Bayes calculator box. So first just do the end cut to get the first 45-degree miter cut.
Measured 322
there.
along here.
And then I used my measurements
pretty close to it.
to get the bottom of that piece miter cut. So just ran through the 4 pieces I need to cut like that, make sure they're pretty much exactly the right length for fitting the Bayes calc poster and the panel inside the box. I had about 1mm gap planned on each side of those things, so hopefully I'm getting this close enough that everything fits in. And then there's one vertical or 2 vertical cuts to do for the piece that runs across between the panel and the poster.
Okay, this is looking encouraging. So this is kind of the wood pieces fit together and put in the Bayes theorem sign and my copper faceplate. They're not at the right height, but gives you an idea how they're going to sit in there. It looks like the gaps should work. I had about 1mm on each side, so it looks like that's enough to fit things together nicely. So it's just a matter of gluing the sides together so everything still remains kind of 90 degrees to each other, but it shouldn't be too hard. And then I can start working on this brass faceplate. Okay, had a better go at working out the layout here, where the knobs go and the OLEDs and the LCD goes. So I got some measurements down here. So 30mm to the first knob, then 50mm between each knob, 45mm from the knob down to the bottom of the OLED should work, and then this worked out about 30mm down to the center of this panel. It gives me a bit of room, so if I have to cut off a little bit off the edge, I can do that. So the next thing I need to do is start center punching this and drilling probably that hole and work out how to cut out the square hole. I'm probably going to do a 3D print to have it have a mount in there for that, and also surround the whatever I cut out for the hole, because it's probably not going to be absolutely straight. So I'll put a little frame around the hole with a 3D print. We'll see how that goes. So I added some markings here, just used a pencil because I can rub it all off. I'm going to clean up the front of this brass plate, but here's with my 30mm in, 50mm between each knob, and then laid out for the OLED holes. These scribbled on areas will be ones I cut out, and then the LCD should fit up there and be able to fit at least 3 switches underneath, which I think I'm going to need for setting percentage or decimals, setting it to 4 knob or 3 knob input, and an on-off switch. So I think that there'll be enough room, and then I can cut a millimeter or so off the end if I really need to.
Okay, working out how to do the metal work for the first control. So I punched a hole that's the center of the rotary dial, and punched some holes around the edge of the where the OLED's going to go. So I'm going to drill out the rotary encoder hole, and then I have to work out how I'm going to cut out the OLED rectangle there. I use the drill press for creating pilot holes where those punch marks are. And I went to drill out the large hole the rotary encoder will go through. Yikes! My drill bit was binding up badly here, as you can see. So I had some offline work to do to work out how to drill a large hole through the thick bronze. I found out I had to work through a series of bits getting larger and larger to get the hole drilled without it binding up. I also had to work out how to cut out that rectangular piece for the OLED. I found best way I could do it was use Dremel and various cutting discs and cutting bits, and that seemed to work. And you'll see with the 3D print I've got for putting a frame around the OLED, sort of covers up most of the worst things I did with cutting out the rectangle, but it's about the best I can do, and you don't really see it when I put it together. So let's get back to the video. Yeah, here's the 3D print I used for my OLED mount and frame, and it has this lip around the top to hide some of the bad sanding, bad grinding and things I did. At the moment it's about 1.5 millimeters. I might have to push that up to 2.5 millimeters around there, but you can get a idea what it looks like. And this top part is inserted into the panel, and this bottom part it's flipped the other way around, but then does a friction fit over this, and seems to fit together pretty tightly. Once I've got this thing almost finished, I'll probably just put a few dabs of glue or something to keep these things together, maybe some Loctite. But that seems to be working okay, and I'll put a link to the Fusion file for this in the description.
So I made a mount for the OLED. So it consists of this frame here, and then this piece here that mounts on the actual OLED. I've got some screw holes there for the screwing it into the OLED, and then the idea is that friction fits together like this, and if I want stronger connection I can glue it to the actual brass front plate. Now the useful thing is, even though I've got jagged edges on this cutout here, I can put this frame in like so. That covers up the worst of my jagged edges, and I can make this frame bigger if I need to. Then over here it just friction fits over the frame, and again I can glue it in to when I'm finally ready to mount this, but it's in fairly strong and these things aren't going to move anyway. And there's our OLED mounted in the frame.
And this shows what the OLED's going to look like in the actual brass panel. I'm displaying some digits using my MicroPython program. I can see some fix-ups I need to do with some buffing and things. We'll see if that works out. So I'll show you how I worked out how to drill out and create the square for the OLED. So first punched place holders for all the holes I'm going to drill. I'm actually going to drill more holes this time. It'll make it easier to cut out the rectangular piece. And now I'll use the drill press to drill out all those punch marks. doing these small holes, drill press had no problem doing line up at all, so can get through this fairly fast. Speed this up. I also wanted to try this with some drilling oil, see if it made a difference, if it made it smoother. Here we go with the oil in place, and I'm drilling through that. Made it harder to actually see the punch marks, so see I had to wipe things away quite often. But I think for the small drill it didn't really make much difference. Now let's try drilling the larger hole for the rotary encoder. This is the one that kept winding up before. So I started with a 1/4 inch drill bit. That seemed to go through fine. I put some oil on there. Then I started using larger drill bits. And this method worked better, but I think I still have to go through more drill bit sizes. I found if I jumped a couple of drill bit sizes it would bind up again, and in the big picture it didn't make a lot of difference. My hole was still round enough to put the rotary dial in, and then it gets covered by a nut anyway, so you don't really see, well, I went off center a little bit, but I think next time I'll run through a lot more bit sizes, so hopefully you can avoid the binding up altogether. So now I'm going to use the Dremel. It's a 1.5 inch cutting bit, and it slices through the bronze or the brass pretty easily. I just have to be careful not to run it over the end, so I have got that frame to cover up most of my sins, or the worst of my sins here, but I still ran over the edge sometimes more than I'd like to. But so I use this cutting bit first. I did it from both sides. It cuts the majority of the metal away that I want, and then I use this little bit. I think it's a diamond head bit. It looks a bit like a dentist drill, but for the thin piece of brass I've got left, it seems to cut through it nicely, and I can quickly run through and get rid of the remaining brass that is bridging the pieces there. Yeah, only unfortunate thing is it's not a perfect sort of cut down the side. You see you've got dents and things where the drill holes didn't line, or the Dremel bit didn't get it totally smooth. So I tried using this grinding bit in the Dremel, see if that helped smooth things off. It didn't really make a lot of difference, so you'll see later I actually just changed to a file to straighten up the edges. But again, with the 3D frame, most of my sins get covered up when I put that frame on there. So here's a test fit. Didn't quite fit the first time I put it in. So I'll file a bit away some of the jaggy bits with the file. It seems to line things up better. Gets rid of the worst of the stuff that's sticking out. And now when I put the OLED frame in, it fitted fairly nicely. And now it'll be tight once I put the friction fit back mount for the OLED in there. So you may have noticed here that using the Dremel and drilling holes and filing out holes wasn't that accurate. At least I wasn't that accurate with it. It helped that I had the 3D frames to sort of hide some of the bad cutting. Probably if I did this again, I'd probably look to using a milling machine to make these cutouts. But milling machines cost a lot of money, even a mini mill. It's probably not worth it for this project. But if I find I'm doing a lot of these, then milling the machine is probably the way to go to get these accurate square cuts into thick metal. This shows what the panel looks like. Now I've printed out all four of the OLED and the LCD frames and mounts. I did them in black. Black seems to look better. And then you can see here where I've worked out how I'm going to mount the PC board on the back for the Pico microcontroller. I got to the point where I'm ready to glue the outside of the case together with the miter joints. So I saw a good YouTube video. I've got it linked to it down in the description, where you can make doing this a lot easier by using painter's tape to secure the joints together so they're 100% aligned. And you can see here, by doing that you get nice tight fit when you bend the case round, and it's almost ready to glue at this point. So I applied just some Elmer's wood glue. And you see here I use the painted tape again on the inside too. It stops the glue spreading onto the wood. I can take the painter's tape off afterwards to remove any excess glue that's on there. I may have put too much glue on there as well. You can see. After I did this, I had to clean up my workbench. The good thing is just water removes this wood glue. I was making a bit of a mess at this point. So I put the final piece of painter's tape around the top joint to secure that, make sure they're fitted tightly together. I use some of these corner clamps to make sure everything stays at 90 degrees. And just check that out, and I'm looking good for 90 degrees. And here's how I left it overnight. So I cleaned up the glue and could just leave it here to glue for set for 24 hours. It should be a fairly strong at that point. So just doing some more test fittings of my case and the base Theorem panel. At the moment it's not varnished yet.
Okay, we're getting closer. I added some switches, so there'll be the percentage or decimal display. That one will be to switch between 3 inputs or 4 inputs, and this will be the on-off switch.
Here's the varnished version of the case.
Okay, I want to mount all these rotary encoders first. I'm going to hardwire the ground and the positive lines together, so there's going to be 4 of them up here. And I'm going to organise these by having a spring washer at the back just to be able to tighten it pretty well. Then on the front, I'll just put a normal flat washer, and then a nut, and that should hold it in place pretty well. So I just tighten that up, and I don't think it's going to move once the spring washer does its thing. Okay, so I put the rest of the rotary encoders in. I also put the OLEDs in, so remember they're just like a friction fit frame there. I'll probably tighten them down. I'll put some probably a Loctite or something to actually put them in there firmly, but for now that's okay. I mounted the board where it's going to go. That's going to have the Pico controller in it, and then switches and the other OLED LEDs in there. And then I just wanted to check everything still fits in the case here.
I started wiring up the panel. I had some heat shrink over these connectors later on so they didn't bang into each other. And these are the main power rails, the positive and the ground rails. I added header pins to the Pi Pico, and then I soldered a header socket onto the PCB, so I can just plug in the Pi Pico board.
Okay, I soldered in extra pins, so I soldered up the main rails here, so ground I've got going to the negative rails here. Positive 3.3 volts goes to this rail, and positive 5 volts goes to this rail, and I put 4 pins on each of them to distribute to the OLEDs and rotary encoders. And then I put all these pins in just following this, so I need 3 pins for each of the rotary encoders. So 1, 2, 3, then another 3 here, another 3 here, another 3 here, so they line up down here. I got 2 extra pins for connecting to the switches that switch between percentage and decimal, and the other switch that switches between 3 and 4 parameter input. And then these 2 sets of 2 pins for the I2C buses 0 and 1, and everything should be able to plug in there. Haven't done much to the actual Pi Pico other than mounting it, so we should be good to go.
So this shows you the wired up main panel, and at least the OLEDs are working fine. So now I need to get the rotary encoders wired up. This should be all the wiring. One of the encoders wiring got a bit cramped, but fitted it in the end. I wired up the switches for the percentage, decimal view, and the 3 or 4 input selector, and I'll add some more cable ties. Let's have a look at the code. I'm not going to go into the detail, I'll just go through the top level program. Some more details in that first video associated with this. So the first thing, I moved all the test code into main.py so that when the actual board gets powered up or when it gets turned on, this code just runs automatically. We've seen a lot of this, but I've set up 2 instances of I2C buses. I need 2 buses to be used because I've only got the choice of 2 addresses for the OLEDs, and to be able to run 4 OLEDs I need to be able to run 2 on one bus, 2 on the other bus, to be able to use the same address for 2 of them. And then I also set up the LCD, which runs on the first bus, because it has a completely different address from the OLEDs, that can run happily on that bus. I set up the OLED objects by using the SSD 1306 library. Again, we saw that in the earlier video. I need 4 sets of OLEDs and rotary encoders for entering the parameters. You can see here for the Bayes formula, so one represents probability of B given A, next one is probability of A, and the third one is probability of B, and then the second option is the 4 input formula, probability of B given A, and then I also need probability of A, and then this alternative version of the denominator is probability of B given A times probability of A plus probability of B given not A times probability of not A. There should be a P in there. And you'll see later on I made one big mistake because I worked out that probability of not A is just the inverse of probability of A. I could have in the end just used 3 dials for the alternative formula as well. I set up a pin to check the switch that tells me whether it's in the 3 parameter mode or the 4 parameter mode. I set up the pin to change between showing things as percentages or decimals. I'm also setting up these last values of the previous value that these things had, because I do a lot of the updating only if there's a change in the switch condition, or even if the rotary dial changes, so I'm not updating OLEDs every time. It just reduces the load on the system. I set up the 4 OLEDs and have their parameter values shown in here, and again that's driven by what the is for dial mode flag is set to, what that switch is set to, whether it uses 4, and what the values are for the last 2. This is an interesting one. So I found that my Pi Pico, for some reason, when it's in a tight loop, I wasn't able to interrupt it with the normal keyboard interrupt by doing a Control-C. And when this is running as the main procedure, that makes things really hard to work with, because basically it's always going to run the current program that's in main.py and never gives you the chance to go in and update it. So what I had to do is I added a little switch to my board, just a little push button switch, and I've got a pin here that checks on that. So instead of using the keyboard to interrupt the program for main.py, you'll see I'm using this is reset pin, and if it's pushed, then it interrupts the program and ends the program, which allows me then to connect in through the USB and update the main.py, which I needed to do. Next thing, and again we saw this in the first set of videos, was set up the rotary encoder classes, the dials, and the only tricky thing here is make sure that the various pin settings align with the actual encoder that I'm trying to control. So dial 1, or the first encoder, uses pins 0, 1 and 2 for the clock data and the switch input coming in from that encoder, and you see what I set the other ones to. So I was really just making sure that I'd wired it up correctly and it all works. It's something I had to do to sort of fudge using the 4th encoder. Once I worked out I didn't really need it, was, like I said, it just represents the probability of not A, and the probability of not A is really just 1 minus the probability of A, which is always been entered through the 2nd encoder. So by default I want to set the value of probability of not A to 1, which, as in the actual dial, that's represented by a value of 1000. I set up the last dial values just so that it can detect when there's a change to the dial values. I display something on the LCD, just to say Bayes calculator, and then I go into my main loop, and this is just going to loop forever unless it gets interrupted. Inside that loop I have a sleep statement for 50 milliseconds, so it'll do 20 of these loops per second, depending on how much work it has to do in these loops. And this is where it looks for the value of that is reset switch. So if that button's been pushed, then it's going to break out of this loop. So that's the way we get out of the loop now. It also checks the 4 input dial mode switch. If that's been changed, then it basically resets, so it goes and restarts the whole main program again. So we lose any values we had in there, which aren't much use keeping if we're changing to a different parameters being entered on the screen anyway. So basically I just start from scratch and restart the whole machine if that dial mode is changed. I've got a little print statement in here, so if I'm watching it I can just see it progressing through each loop with a little dot being shown on the console. I go and checked if the percentage switch, percentage display switch has been switched from percentage to decimal, if that's been changed, or if any of the dial values are getting changed. So it just goes and checks all 4 dials to see if it's got a new value in there. If any of those things are different from the last value, then I just set the flag display refresh equals true, otherwise it's set to false. And then in here, if display refresh, this is all the things it does if it sees there's a new value being entered or the percentage switch has been changed from percentage to decimal or the other way around. So first it clears the OLED 1 value, any value in there, and sets OLED 1 to whatever the percentage mode is. And then it does the same thing for the second value, but this is one of the ones that represents probability of A. So the tricky thing I did was, as you change either this encoder, which is encoder number 2, or encoder number 4, it just changes the value on each to be the inverse. So kind of a redundant thing. Like I said, didn't really need 4 rotary encoders in the end, but at least this seems to make it look like it's doing something useful. If you're using that 4th encoder, it'll reduce the second value while increasing the 4th value, or do the alternative of decreasing the second value while increasing the 4th value. So it looks like they're doing something useful, but again, that could have been calculated rather than doing this. So I do that. Then for OLED 3, I just clear the value and then set this percentage mode. And OLED 4, like I said, it's doing the same thing, but it is also adjusting the value on the second parameter to be the inverse. So once we've got all that sorted out, I must have some good values, or have some values entered on the rotary encoders. So I just reset the last is percent value, so I can check for has there been any change next time. I show the value on the first 3 OLEDs, and then if we're in 4 parameter mode, I also show the value on the 4th OLED. Otherwise it's just stays blank. There's no values showing on it if we're just in 3 parameter mode. Just reset the last values for the 4 encoders, so again we can check for changes, and then we do the calculation. So I clear the LCD, so this is the main output, large LCD. By default I set the result to -1, just indicates that no valid calculation was done. And then it does one of the 2 calculations depending on whether it's in the 4 input mode or the 3 input mode. So let's have a look at the 3 input mode first. So if it's 3 input mode and the divisor is not equal to 0, otherwise we'd just want to leave it as -1 as an invalid value, then we get the result, which is basically the Bayes formula of the first value times the second value divided by the third value, which is probability of B given A, probability of A, and probability of B. And then we do the more complicated version of the Bayes formula using my pseudo 4 values here to get the result for the 4 dial mode. Then we show the result. So first, if the result is -1, it means it's an invalid value. So we're either dividing by, we're probably dividing by 0 for some reason. So in that case, it just shows NA as the result on the second line of the LCD. Otherwise, if we have got a valid value, then it displays in the LCD either as a percentage value, so we divide the result. So remember that's between 1 and 1,000 by 10 to change it to a percentage value and show a percentage sign at the end. Otherwise, we are displaying things in decimals, so we divide by 1,000 to get a decimal out of the maximum value of 1,000. Just throw 3 significant digits and display that as a decimal result. So that's about it. And then, like I said, if we break out of the main loop because we press the reset button, I've just got some console messages to say we're exiting. I probably won't be looking at that anyway. And I just clear out the 4 OLEDs, make them blank, and then just show on the main LCD that we entered because of the reset. Okay, so this is the finished calculator. I set it up, put some
fancy plates on the corner protection plates, and I can hang it up. I've got a hanger on the back, so when I turn it on, it fires it up. In this case it's in decimal mode. I can flip between decimal and percentage mode. I can put some random values in here just to show what it looks like, and then calculates the Bayes calculation based on that. And I can also flip into the 4 input mode here, which has some different input values for the 3rd and 4th values, and input values in here to calculate things as well. So that's it. So the next video I'll actually get into doing some Bayes calculations on this, do some examples, and hopefully they'll be a good background on why Bayes' theorems are kind of neat and all the things you can use it for. It won't be an in-depth one, but I'll try and make it interesting and fairly short, just to go through some different uses for Bayes' theorem.